Good morning. Welcome to the next session. So, in the last session, I have told you about the machine learning algorithm, and I'll continue with that. And what we say that we have a shop or what we call as a apparel shop, and I want to find out the demand forecasting. That means which apparel has been sold, and I want to predict which apparel or which cloth will be I need to grow from the warehouse. So, what we say that the model simply will take a average demand of each item last 2 weeks and an estimator of the future demand. So, whenever I want to do a future demanding forecasting, okay, or what we call as a predicting in our machine learning algorithm or in our data science, statistical model like this are frequently being used for the real story. Okay. So, to be more general, let us call this as a forecasting as a variable. So, we call this a variable in our machine learning and data science as a target variable. Target variable could be the number of items sold, the number of items bought, or target variable could be basically increasing the number of customers. So, a target variable is a variable which is of a demand. So, to build a forecasting model, we will use 2 previous weeks of historical data to calculate the arithmetic mean of each and every item. We then use those averages to estimate the future values. In the way historical data are very important, so that I will be able to forecast that. So, prediction is more or less predicting a future requirement. Okay. So, we say that in historical way, historical data was used to teach our model about how it should predict the target variable. When the model learns to perform a given task using a input output example, we use the word supervised learning because I know the answer. So, when I know the answer, okay, I am trying to predict the answer, but the value is a known value. So, this kind of learning in our machine learning and data science is a supervised learning. And supervised learning has not limited to simple model. In general, more complex model can be available, and more training data you have, better model will be. So, in a supervised learning, more training data I give to my model, the better accuracy I can achieve, or my model will be trained for a better results. Okay. So, for example, let me tell you, let me take another example number 2, world of information security. And as our name of the course is also managing data science with security. So, security is a major concern for all of us, especially in information and communication technology. So, let us say I have Jio, Idea, BSNL, Airtel and so many number of telecom industry in the India. Okay. So, our imaginary client is a large telecom company out of one of them. Okay. Over the year they have experienced many security breaches in their network. So, whenever I am trying to do a Jio money transfer or a Airtel money transfer, Airtel as a base transfer or Jio as a transfer or any financial accounting or financial transaction I am doing, I have a lot of security breaches available. So, thankfully, specialists have recorded and thoroughly investigated all the activities which are basically what we call as a fraudulent activity. So, I have a fraudulent activity, that means somebody is committing a crime, not a crime exactly, somebody is trying to use my debit card detail, credit card detail, my PIN number and things like that in order to steal my personal information, in order to steal my account information. Okay. So, security expert label each fraudulent activity across the network as a log activity. So, whatever activity I am doing on the internet, please remember clear of your log. Okay. Otherwise, it will be able to remember, and last time whatever activity we have been doing, it will be available to the other person which is unknowingly known to known. So, having a lot of data with label training example, we can train a supervised model to distinguish between normal and a fraudulent activity. How do I know that it is a fraudulent activity? If I am, my spending pattern is, let us say 1000 rupee per day, or on an average around 2000 to 3000 rupees per week I am spending, and suddenly I find that okay, from my account 20,000 to 40,000 has been debited. This is exactly something called as a fraudulent activity, because the model will know that what is your normal expenditure over the period of a time. So, suddenly a jerk come, suddenly a upswing come in your expenditure. So, that expenditure, the service provider will alert you saying that, oh, is it you who has made the transaction. If you say no, you can alert and stop the payment also. So this model will recognize suspicious behavior from vast amount of incoming data. However, this only be in case if expert label the data correctly. Okay, our model will not be able to correctly identify. So this is the problem with the model, garbage in, garbage out. So you have to have a very good model which will be able to do the fraudulent activity checking. Okay. So both the retail and security example use a supervised learning, but let us look at a target variable more closely. The forecasting algorithm use a demand as a target variable. Demand is a continuous number. So number may be 100, 200, 5000. So demand is a variable, have a value is equal to 0 to 1000, 2000, or in general we call a value between 0 to infinity. On the other hand, the security model has a fixed number of outcome, either fraudulent or not a fraudulent, either a normal activity or a abnormal activity. So this kind of model will predict a outcome is equal to classification problem, whereas the first one is a regression problem. So network activity is either normal or fraudulent. We call the first type of the target variable as a continuous variable whose value varies from 0 to infinity, and the second time is a categorical variable because your outcome is either yes or no, fraudulent or not fraudulent, normal or abnormal. So the target variable strongly indicate the which kind of task we are trying to solve by ourselves or by the model. Prediction tasks with the continuous variable are called as regression problems, which we know, and when we total number of outcome is limited, we say that we solve a classification problem which is pertaining to the second one. Classification model assign data point to categories, where regression model estimate the quantity. So this is the underlying difference between the two kinds of machine learning algorithm. Here are some example. Housing price estimation is a regression task. Housing price. So I want to buy a new house. The pricing of the house or rented house is a regression problem. Predicting hard disk utilization on a cloud server is also a regression task. And identify the risk of a credit card file is a classification task. Whereas predicting user aid click is a classification task. So you can see that the person like the ad or not, or he won't like to see another ad similar to the one or not, is a classification problem. So these two are basically for our learning purpose. So you can consider yourself lucky if you have found a good labeled data set. So what we do is, if your data set is very good, we are able to train our model. If the data set is not good, then we use data augmentation technique to increase the artificial data set, and we try to solve the problem in the hand. Okay. So a learning process where target variable is missing, sometimes the target variable is not known. So what you can do it, we have a term called as unsupervised learning. I do not know what variable I will be using. So we have to derive a algorithm where I go for a unsupervised learning principle. So while supervised learning implies data is labeled, unsupervised learning removes the limitation, allow an algorithm to learn from the data itself. So example is, marketing department may want to discover new segment of customer with similar buying habit. So I do not know the answer. So can I discover the pattern of all the customers from the last few months, what they are buying, what they are interested about? Then those insights can be used to tailor marketing campaign and increase the revenue in each segment. So this kind of algorithm is a unsupervised learning. One way to discover hidden structure in our data set is use a clustering algorithm. Clustering algorithm means make a group of people who are having a similar interest or similar buying capacity or habit. So many clustering algorithm can work with a unlabeled data set, and this characteristic make the data very interesting. So for example, look at here, music. I want to generate a new music. Music is a very close to the human brain and close to the human heart. Everybody like a different genre of the music. Somebody would like a classical, somebody would like a Karnataka music, somebody would like to have a different kind of music. So sometimes label hide the data in the raw data. Look at the task of creating a music. Suppose we want to create an algorithm that composes a new music. This is what our film industry does. They listen to some of the music of the old song and try to reinvent the whole music. True. So we can use a supervised learning without explicit labeling in this case. The next node in the sequence comes as a great label for the task. So starting from a single node, I can design a new music. Now this is a very good applications of machine learning algorithm, deep learning algorithm in our data science. So generating a new music is a wonderful job. Okay. Game. For example, gaming industry is also very important and is also closing to you. So, I have shown you a particular game. A game is basically you give a game to the people, and then people would be having a strategy either to win or to lose. So, every time you win, you give a plus point. Every time you lose, you give a negative point. This is the gaming industry, very popular. Okay. So, let me start with the introduction to of our deep learning algorithm. But before I start, let me give you a idea about the gaming, then I will finish. So, gaming has to have a very good knowledge about the machine learning algorithm that will learn how to play the game. So, whenever I want to learn a game or a new game I want to design, I have to know the frame of the rules. Once I know the frame of rules, it might be tempting to use a supervised learning, but at first you have to have a training data which will look controller at the first time of the life. You can create a algorithm that figure out the game by themselves. So, you can create a new game, you can design a new game using a supervised or unsupervised learning depending upon the task in your hand. So, I finish here, and thank you so much.